Welcome to this video, and in this video I had some students that wanted me to go over a few more examples of how to use the unit circle to determine these cosines and sines and cosecants and all the trig of these special angles. So I'm going to go over a few more examples here. One of the things that you just want to keep in mind is that the x-coordinate is the cosine of that angle, so it's the cosine of theta, and the y is the sine of theta. If you keep that in mind, you'll be fine the whole time. So just remember that the x is the cosine and the y is the sine. And we get that from if we drew a right triangle here. And this was my x coordinate, and this was my y coordinate, and sorry, the hypotenuse, which is the radius, is just 1 because it's a unit circle. And this angle is theta here. Then theta is going to be the, if we do sine, is going to be the opposite over the hypotenuse, which is y over 1, which is just y. Same thing, the adjacent over the hypotenuse is x over 1, which is just x, so that's our cosine. Anything else, we're going to use those properties that tell us that the tangent is the sine over the cosine, and forgive my abbreviations here. The cotangent is the cosine over the sine. The secant is 1 over the cosine, and the cosecant is 1 over sine. All right, I want to make sure I have my thetas in there. Okay, so if we're looking for any of these guys, tangent, cotangent, secant, or cosecant, we're going to want to use this. But for anything else, we just use our fact that cosine and sine are x and y's. Okay? So let's say we're looking for the sine of 60 degrees. So all we do is go to 60 degrees on our unit circle, which is right here. And then we want the sine of 60 degrees. So the sine is the y value. So the sine of 60 degrees is root 3 over 2. And that is it. That's all we do. If I want the cosine of 5 pi over 3, I'm going to go and look for 5 pi over 3 right here. And I want the cosine of that. The cosine is the x-coordinate. So my answer here is 1/2. That's it. Now the cosecant over here is 1 over the sine. So I'm going to go over to my angle, which is 7 pi over 6. 7 pi over 6 is here. I want the cosecant, which is 1 over the sine. The sine is the y value. So the sine of 7 pi over 6 is negative 1/2. So the cosecant is going to be 1 over negative 1/2, because this is the sine, remember. And then we're just going to take and do the reciprocal of that. So I'm going to have negative 2. That's my answer. Okay, so that's really all there is to it. Okay, so let's take a look at excuse me. Let's take a look at something that's maybe not on the unit circle, like cosine of negative 5 pi over 6. Well, negative 5 pi over 6 is not on here, but you do know from a previous video that a negative angle is going this way. Okay, it's going clockwise and not counterclockwise. So we're going to go ahead and look on the unit circle for negative 5 pi over 6. So we're going to go negative 5 pi over 6 radians. So if we went 5 pi over 6 radians, it's going to be about 100. That's going to be 150 degrees this way. We're going to go negative 5 pi over 6 radians. So we're going to go 150 degrees this way. And that's going to end us at 210 or 7 pi over 6. So what we're really looking for is we're looking for the coterminal angle of negative 5 pi over 6 that's in the unit circle. All right, so this right here is going to be the same value as cosine of 7 pi over 6 because these two angles are coterminal. So this went negative 5 pi over 6 here. And we're going to end up with the cosine, which is the x-coordinate, which is negative root 3 over 2. Okay? And that's the answer. All right. So you can do that. Another thing you can do to find this coterminal angle is, since you're going negative 5 pi over 6, you can add a whole revolution to it and see what your positive coterminal angle is. So what I'm saying is, you can take 2 pi and add it to negative 5 pi over 6. And if you do that, we're going to change 2 pi to 12 pi over 6 to get a common denominator. So notice 5 minus 12 is 7. So that'll give you your coterminal angle if you're looking for the coterminal angle. All right, so let's look at number 5 here. Tangent of 22 pi over 3. Now this is a different case in that we've gone around the circle more than once in this case. So how many times around the circle have we gone? Well, remember that every 2 pi is going to be 1 revolution. So every 2 pi is going to take us back to the start. So we're going by threes here, and when we go by threes here, what we're going to do is, well, if I go around the circle once, that's going to be at 6 pi over 3, right? Because that's 2 pi. And then I go around the circle again, that's going to give me 12 pi over 3, right? Because I've gone another 6 pi over 3s. And then I go another 6 pi over 3s. It's going to give me at 18 pi over 3. Okay, so this is around the circle once. This is around the circle twice. This is around the circle 3 times. And then what am I left here? Now I'm starting from the beginning. 18, 19, 20, 21, 22. It looks like I have a remainder of 4 pi over 3. So when I get to 18 pi over 3, I'm going to start here again. Then I'm going to go 4 pi over 3 all the way right here. And then that's where I'm going to finish off. So it looks like here, this is going to be the same as tangent of 4 pi over 3. Okay, it's coterminal. 22 pi over 3 is coterminal with 4 pi over 3. So the tangent is the sine over the cosine, which is the y over the x. So here I'm going to have negative root 3 over 2 divided by negative 1/2. All right, and that's just going to give me positive root 3. All right, last one here. On the secant, well, we'll deal with the secant part of it last. And the secant part of it's easy. We just go to 1 over cosine. But we really need to deal with this coterminal angle. Now, this is the best of both worlds here. It has both of these guys here. So we've gone around the circle more, but we're also going in the negative direction. So let's deal with this part first, and then we'll go over in the negative direction. So let's do the same thing we did last time. 12 pi over 6 will get us around the circle once. And then 24 pi over 6 will get us around the circle twice. So this is 1 revolution, this is 2 revolutions. 24, 25, 26, 27, 28, 29, 30, 31, and we have left over 7 pi over 6. But we're going in the negative direction. So from here, we're going to go negative 7 pi over 6. So had we gone all the way, it would be here. So negative 7 pi over 6 is going to be this far. Okay, we can add 2 pi to that. It'll give us 5 pi over 6. So we're really looking at the secant of 5 pi over 6. And the secant is 1 over the cosine. The cosine is the x-coordinate. So we got negative root 3 over 2. And we're going to simplify that, and you simplify that out. And we're going to have negative 2 over root 3, which is going to give us negative 2 root 3 over 3 after we rationalize the denominator. Okay, that's it. If you have any questions, go ahead and ask me below. If you're in my class, there is no whisk for this. This is just an extra examples for your help. Thanks for joining me. Bye.